Okay, sure. Good morning, everybody. I think probably we should start. Otherwise, I don't know how long we'll wait. So, how many problems you guys have solved so far? Because anyway, I did not ask you to solve it exactly what the statisticians would do. But the problems we discussed essentially, I don't think that even statisticians has the solution really to solve all these problems, and that's why it requires everybody. So anyway, I think today probably I'll start some of the smaller pieces of statistical methodology, and then we'll discuss when we have to handle the bigger data, then what would be the situation. Okay. So as I said, that we'll start with, so regression analysis is one of the very, very important statistical technique which being used in every field of science, including business, social science, engineering, everywhere. Some cases it is simpler form, some cases it is complicated form, but the concept of regression is everywhere. Even if you do the machine learning, essentially one kind of regression you do. So we'll start with a very, very basic thing, and then very quickly probably we'll move to much more advanced technique. Let's start with, to do that, let me pose some questions. So let's, yes, any comment? Okay. So as you can see that I love to develop the problem right from the beginning rather than doing the formula. So I won't tell the formula exactly. So you can come up with these things. So let's, I heard that the government is basically building number of new IITs. So it's not a good example, but since I am in IIT, so I thought that I just made it up. But you know that whenever you plan to build as a new industry or new store, you need to have some idea why you will put that store. Like Walmart is thinking to do business, say in Delhi or Bangalore or Bombay. They're not going to come without any predictive informations in terms of whole operational cost, in terms of what should be the profit, long-term profits, short-term profit, risk calculations, many things they have to do before the management can take a call whether they will come to India, and if it is in India, then which part they will come. But very simple thing. So just prototype way, that we like to do this thing. So the initial idea, and since we are trying to think about everything, of course there would be number of qualitative factors, all other things would be there. But being a data scientist, how we can help in making that type of decision. This may not be a good example, because possibly this type of decision comes in India completely different way. There is no data, nothing. It is all other factors are there. But think about just some modern corporate world like to open a new business. So what should be the starting point? Being a data scientist, you are the part of the whole management team. How do you help, or what would be your idea? So you have to basically formulate. So as I said that out of the 5 points, the first thing is the hypothesis or the problem. So there is a bigger problem, pin down a small thing. So what is the parameter? Probably you may target about the first budget, how much money I need to open an IIT, right? This is the big factor. So that among the all other associated things, that's the big factor. So we pin down one thing at this point, but there could be numerous things. I'm not saying. So let's do, if we can solve this thing. So how do I tell, or how the government would know how much money would be needed to open a new IIT?
So we can see what the other IITs, how many departments we have, what was the initial cost we started at, and we can match up with the same.
So you would be looking for related data. Exactly, good thing. So you'll be basically if we question the funding, somehow I made this thing up as well. How do I know these things? So essentially, you look for related data. That's what you said, that look at what is the related data, existing IITs, and how much money needed for these existing IITs. Right? Forget about even, because IIT means it could be, to define IIT, then there are thousands of variables are there, which, like, as you started talking about, that number of department, number of people, number of lab, number of this type of employee, number of students, number of blah blah blah, all sorts of things. But we can keep talking all these things. Possibly the data will be coming, but the more data means good, but more problem as well. And a very simplistic thing, we can think about how much money was needed for the existing IITs. That should be pretty easy to understand, or currently how much money they are spending. It's very easy to understand. So if I have this thing, say for example we have 10 IITs, then you get that number from the government record book. Can I, with this particular information on the table, when we will having the meeting with the management, can I say something? Answer is yes, because we can just, this IIT, if we think, so there are underlying assumptions which we will never explicit. If we think that the new IIT is going to be one of the replicate of the existing IITs, then certainly if I calculate the average value of the, or average funding of existing IIT, that could be a reasonable answer. But note that the assumption is that you are thinking the new IIT could be kind of replicate of one of these things. It won't be completely, it won't be Harvard or it won't be Stanford, nothing like that. It would be similar type of thing. But if you are thinking completely different way, your answer going to be wrong. So, so that's a good starting point. Again, that's with the data. So this is definitely an acceptable answer, but nevertheless, for that answer, we don't need to come to this class, or even nobody needs to take a stat class or anything, right? So no need to have a data scientist. So there is no demand for the data scientist. So why it is so? Because this is a very, very naive answer, and really it doesn't give much other than just a starting point. Like it's kind of a step 0. So how do I improve the, so already why this simple answer is not very precise, and the reason is that the average is just average. It doesn't have any preciseness in some sense. Like if I tell the average percentage score of a class, that you get some idea, but it nothing to do with what one individual got these things, similar type of things. So in some cases it could be a huge error, and some cases if you are lucky, maybe minimal error. For example, that person very, very close to the average, in that case it would be good answer. So what does it mean? In reality, if I do that thing, that means if the IIT which we are planning for, that's kind of matching the average cost of existing things, then answer would be right. But there is no guarantee, nothing, all these things. So in that way, as I said, that the answer is not very precise, or this should be reasonable only in a very idealistic situation. It could be reasonable. So sometimes it's kind of the luck, or you say, oh, you said I told you that it will be like this, but essentially you can say this was the case. You are lucky that's what it happened, but otherwise it should not work. So how to improve the answer? How can I be more specific? From a data-driven perspective, of course, we need some data. So let's think about what should be the related data. So not only the data, we can have tons of data, but it has to be related data. So one of the related data we can think about, as you said, number of employee. Of course, again the employee varies depending on what percentage of the professors, what percentage of the students, or percentage of the staff members, that cost differently, what kind of different departments are there, how many labs are there. But short story long, we should go step by step. So certainly the number of employee is the one of the big factor which we could match. So then from the data where you made the average, so for each of these things probably you would look for how many people are working. That can give you these things. But if you get this part, how would you improve your answer? So besides before that, what we talked, that kind of, if I generalize or if I try to give some mathematical understanding why this should be reasonable or why this won't be reasonable, then essentially you have to understand the mathematical assumptions what we put when we build that statistical mechanics. So as I said, that one of the, it would be good answer only when all the values are pretty close. Like there are 10 IITs data you are taking, all IITs data is very close. Then the average is certainly going to be very close. If the data are very wide different, then average is, the prediction also going to be wrong. So that means you have to find some assumptions, and the accuracy depends on how equal the existing IITs are and how different the new IIT will be. If the new IIT, if all existing IIT is very much equal, homogeneous, what is called the homogeneous, we can write in mathematical way, but essentially it represents the homogeneity of all these IITs. If your new IIT under this homogeneous class, then this answer is going to be very good. But once there is not homogeneity is there, not only that, if your new IIT is kind of different from this existing class of IITs, then your answer is not going to be reasonable. But all these things you can try to understand. So as I said, that I won't write the mathematical things but if I interpret all these things, that boils down to this thing, that when the answer is right, when the answer is not right. So can we do better? The accuracy might depend on 1,000 dimensions, because as you said that it many factors. Some of them could be measured, some of them could be measured and controlled, and some of them you may not have any control. For example, we already said that the number of employee, number of department, number of labs, those could be controlled and accurately measured. But some of the things you cannot control. For example, it will depend on a particular city, and city is not under your control. Because city to city there is some variation, doesn't matter, like 100 people working in Kanpur versus 100 people working in Delhi could be different. Although they are in IIT, with 2 IITs, but the total expenditure could be different, right? So for me, and that not under your control. So sometimes we call this is the regional effect or something, but anyway, those things which you cannot control oftentimes, so that's why your model has always some error. The more you can measure all these things, ideally your error will reduce. But on the other hand, more if you do here, you'll end up with having a lot more trouble because of high dimensionality, all sorts of things will come in. So nothing is really one direction, everything you have to think as a whole package. But in any case, why your model has the error, whatever you do, if you do anything from the data, you have to always understand that there will be some part which you cannot measure. But you can actually give some physical interpretation that exists, but I just don't have mathematical measurement. But we have a way to explain mathematically, we just cannot really pin down or cannot control these things. But we can measure, like how much is the error I have, I should be able to measure through using the data science. And that's called the quantification. It's not really qualitative, it would be much more quantitative. And we can use that probability theory to measure these things. But it is not controllable, we cannot control, okay? So, so that's why we'll concentrate on these factors. Oftentimes, in a different context, it will be sometimes called the predictor variables, sometimes it will be called auxiliary variables, sometimes it will be called feature variables, whatever the way you say. So, consider just one out of the numerous number, just one. Say, for example, the number of employee. So, we can improve our previous answer, condition that, note that only when, if the total budget depend on the number of employee. In case this thing doesn't matter whatever the number of employee, then really it's not going to help you. So, so that is definitely important. So oftentimes what I am trying to say, I have number of other feature variable doesn't mean that all variables I need or all variables will help me to make the answer better. Only some of the information, additional information, improve my answer only when there is some relationship. So, idea is to find out the relationship. Now, we can actually generate immediately just to understand what does it mean by this. That means what I said, that your answer would improve only when the additional information what you are bringing that is related to your target. Now, what does it mean? So that means, again, we like to, there is a, we think that there exists some relationship or very natural, for example, here to the total budget and the number of employees. But what is that relationship is? How can I explain that relationship is? So in other words, say for example, if I go to a store, then per item it is listed like $2 per doll. Then if I buy $5, I know exactly how much I am paying, $10, because the relationship is essentially unit times the dollar. Or if there are 10 students are in this class, everybody is paying the same tuition fee, then we know how much is the total, because that relationship is very clearly defined. But do you expect anything like here would be exactly defined, like number of employee versus number of the total budget? So in other words, suppose you have these 10, that's what I think let's dig in. How about we just dig in here? Let me create a just a data set for you guys, and that probably would go. So you can see that so everybody has the R, and who doesn't have, you installed already, right? You can follow me if you have this part. Okay, so I won't do any fancy thing. I'll just create some. So you guys said that you will calculate. So let's first calculate the mean without any other information. To do that thing, say I'm creating a variable called say budget, that equals to, so how many IITs you like to put, say just tell 5, give some number. So how much is the budget for this IIT? Anybody has any idea? 500 crores. So let's put that 500. Okay. So then give me the 4 more numbers. Which one is the largest? Which one is the largest? 500, then another is 700, another is say maybe 400, another one is 450, another is 575. 1 2 3 4 5. Let's put 2 more. 625, and maybe another one is 600. 1, 2, 3, 4, 5, 6, 7. Maybe I'm just making 10. It could be same as well. Okay, that's we don't need to worry about. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 590. All right. So these are the numbers you guys provided. All right. So that R is how nice you can see that. If to calculate the average, I'll just do that mean, and then I'll put that. Everybody can read this thing, the screen. If you are familiar with R, it's too simple, and that's why you need to show the average is 539. So our answer at this point, show your predicted value or what you are projecting for the new IIT. At the very beginning answer, your initial answer is 539, right? That's what you all agreed about the answer. 539,000 539 crore or whatever you need. That's immaterial. All right. So that is our answer number A, or very basic answer without doing much of data analysis. So now, as you said that you think the number of employee is related to these things. So let's put the number of employee. So by doing this exercise, actually what I'm trying to help you to, you can see that how easy to enter the data here as well. You can do this exercise essentially in Excel, but our target is eventually you'll solve bigger problem from here. So that's what Excel is not good thing to do. So how many employees are here? In couple of thousand? Couple of thousand? So 2,000. We can calculate again. See that since these numbers, I can see that even you have the doubt, which means that whatever, when you are trying to make a data-driven inference or the projection, we always depend on our model. But model depends on its data, and data itself may not be exactly right what you are recording, because these numbers has some error as well. So where all this thing goes, that's what doesn't matter how good your model is, you have to always think about whatever I am saying, there is some error. And as a data scientist, can I say something about the error? So that's the most important thing. And that makes the difference from computer scientist to the data scientist. Here the error means the number of times I'm making the mistake, not that I don't mean that one. What I mean much more, when I am saying an answer, I'm trying to say my answer could be this much amount different from the truth. But how much this amount? I should have some clear idea. And then if I understand this model, if I understand all the assumptions behind the model, then if I apply the theory, I should be able to, and that's why we need to develop the theory, and we should be able to say this answer is reasonable, but there is error, but I can say this how much error it could be. Okay? But most often people do not care. But that's not the case. The better way, the more control you will have on everything, the more I think validated mechanism you will have. So let's put that 9 more number, 2000s. Then since it is 700, maybe a little bit more, less. Why don't you guys send me the number? So I should put this number so that I don't calculate anything behind. Go ahead, give some number. 1500. Okay. Okay. Go. 3000, fine. whatever you think reasonable, because as you say, every time you have to solve the problem in the real life. Don't think about, and in textbook type oftentimes we don't question because somebody already gave the number. So 3000, and you know that in textbook oftentimes it's a made up example, so that whatever we are teaching you in theory, it should match. I got 1, 2, 3, 2500. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I think one. Oh, so how much you said?
2700.
Are done? 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, one more I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I have this 10 in the budget. So employee we should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So one more number.
2750.
Okay, that's fine. All right. So we get employee. Now what is our idea? That we thought that, so already I gave the answer, one type of answer, that you can use this information only when that is related to these things. Now the question is what kind of relation it is. I gave one example like mathematical relationships. Do you see what relationship here you can have?
There will be some regression budget is.
Okay, so before I didn't want to use the word regression. What we wanted to understand, whenever we say that this thing is going to help me in predicting this, my study one, then we need to understand what is the relation and how do I know the relationship. Essentially you need some visualization. In some cases you should be able to do the visualization, some cases you may not be. So if I do the visualization, that would help you whether a mathematical relationship even possible or not. So in other words, at this point I'm completely open. It might happen that each number is multiple of one of these things, like 2 times this thing is this or something. If it is there, that's perfect. The world is so perfect, things should have been nice. We don't need to understand anything beyond this math 2 plus 2 = 4. But let's see whether that is true or not. Probably with these few numbers you can see that is not the case. In a very large number of cases you cannot see just by looking this number, so you can do simple visualization. And for this, typically this is kind of the simplistic situation of building the model. In this case we can apply the simplistic visualization technique, what is called the scatter diagram. So this is also R is very good in doing the plotting. So you can do in any axis. It's essentially 2-dimensional. So in a Cartesian system you can plot x-axis, y-axis, you put anything. So let me put either way, so it doesn't matter. This plot you can do much better with some symbol, etc. you can do, but at this point we don't need to do anything. So now everybody understand how to interpret a plot, right? If here somehow this is the budget, so if there are about 1700 employee, then budget would have been like this. If there are 2000, budget would be like this, but it's look like scattered all around. So tell me, everybody had that basic math class. Tell me any mathematical formula for this relationship. So first thing, what you like to see again, this you thought because there could be some relation, and that relation means some kind of trend. So the trend, simplest trend is upward trend, downward trend. Little bit complicated trend is cyclical trend. but look like none of the trend is really is working here that well. For example, these two guys are killing. So for example, here you have only about 1600 employee, but the cost for that IIT is over 600, whatever this number. And for this guy, it is only about 1000 employee, but it is costing you a lot more. So which means that some of these couple of IITs are not following the rule of that their funding rule is proportionate to the number of employee. That means they are special group, probably they are elite group. They are Kanpur IIT, so that's why they should get lot more money, even though they have. Everybody understand what we are trying to immediately you are not ready to do the regression or anything. First you have to understand what the data is saying. So clearly what we can, so what, in other words, what I am trying to say, if I didn't have these two data point, then probably here I could see some little bit of upward tendency. But with these two creating some of these issue. So either you have to think about these two IITs are very different than the other IITs. If you think that way, immediately you should not keep these two into your model. Because it is not going to, it's kind of a, since we are trying to still do the average type of thing, then these two may actually kill your whole model at this point. Right? Because just think about it, if you don't do this, like let's remove these two somehow, and then you can see little bit of upward, like if you have more employee, then the budget is a little bit more. Although there is no exact relationship, but you can see this thing. But that trend is killed by these two. So what does it mean? But note, always we have that assumption, underlying assumption, we assumed that IITs behaved similarly. They may not be exactly the same, they behaved similarly with respect to the number of employee. But if you have these two, the budget is not following similarly, so that means these two cannot be kept into our model, and that will kill our predictive things. Okay? So to make, so this is the first stage of your, so visualization help you at the very beginning to develop a model. Okay? So how about either we modify these two or we just delete these two at this point. So what are these two? One is 700 with 1500 employee, and the other one is 625 with no, it is not 625, it should be around here.
1700.
So let me just modify the data. So we'll do this thing, we'll come back again that what to do. But first thing, you have to be very clear that this can create immediate some problem because it's violating some assumptions on the basis of that what you are trying to predict. So let me just revise budget in that way. So the revised budget, that equal to, the first one is fine, I think 500, then this one is 700, so I won't keep that 701. Let's keep this 400. Then this one is 600, right? I think this is 600, or I don't know exactly. There are number of close to 600, but 600 with about 1700 employees. So okay, let me put 500, 400, 450, or if I just rearrange all these things, that should be probably better. What is the smallest one? 400. Then second smallest one 425, right? Third 450. Next 500. Next 525. Next 5, how much? There is a 510. Where is 510? Or you just modified? You just modified, okay. So 400, 424, 450, 500, 525. No, I'm trying to put in increasing order so that I'll have better control, because we are just making it up here. 545. Not the, I'll just take from here. 525, then 590, then 600, then 625, then let's take still we can keep 700, but think about just it's a different setup number 1 2 3 4 5 6 7 8 9, that is fine. Up, what happened? Why it's a error I got? Oh, so this my it's kind of a little different data set in that way you can think about, and put this employee, revised employee, to see. So if we start with 2000, maybe 50, 3000, 2075, not exactly in upward but kind of upward I'm making, 4000, 3500, 1 2 3 4 5 1 2 3 4 5 6 7, 3800, 4500. Okay, so how about now we do the plot. All right, now how do I, so clearly I can bring back the previous one. This 2 is gone. Now what do you see? What does it say? So first thing, there is no mathematical formula. No matter how good you are in mathematics, you cannot find any mathematical formula which can explain that x equal to y, x equal to y to the power 1 over n, x to the power x equal to y to the power something, even nonlinear, whatever the way, you cannot find. So in other words, what I'm trying to say, you don't need to think about even in a linear thing. Think about even non-linear way, like exponential of the x, y equal to x to the power b plus 3 to the power something. You just do whatever you can. Can you find any relationship which represent all the data point in a single formula? So just to use minimal mathematics, in other words, we do not have, there does not exist any f for which if y is the budget, this size is the budget, that equal to that function, and x is this employee, there does not exist any f which satisfies this thing. On the other hand, like the sales data, there always exist an f for which you can represent y equal to fx. So this is the situation, immediately bring you to the model which would be responsibility for the data scientist, not for the mathematician. Because if it exactly it happened, if there is exactly one f for which this formula happens, then there is no data science. Essentially, it's a mathematics. Everybody is clear? So now the question is, yes.
Just from, even if I don't have any kind of f, but still, can I project these values with some interpolation? What I'm trying to say, even if I don't have any specific form of f, can I formulate this problem, or rather this relationship between y and x, through an interpolation formula? Because the reason I'm saying, because if I'm given any data set or any numbers, data set, any numbers, then I can construct a function using different type of interpolation, but idea is to use that interpolation. So at those particular values, it will eventually match.
It can match that particular value, but you are exactly right. We can match this thing. Few things might happen. The first thing, that doesn't mean that if I bring any other point, similarly, it will follow. No guarantee. And second thing, that function may not be usable. The reason what we are using for. So because what you will be using for, if you have a function, then you like to have for this new IIT, you like to have a new number here, like you are fixing how many employees you will have, so that you can project, but that new number would not have, when you have a new x, you won't have that particular f, because you don't have the data. So what he's saying, that I can have a f value, exact calculation somehow, for each existing point. I can do that. Particularly if I have large number of points, I can do that even. But this thing may not be usable in this sense. For the new point x, I don't have this y value actually. So there is no guarantee that I will find one of the exact f from your existing f's. So some level you have to make some approximation. Otherwise it is not doable. So I can fit the data which will pass through exactly say existing points, but I cannot really extrapolate this thing which would exactly match with the real data. That makes sense? So that's what always I try to say, come beyond the mathematical thinking, but then if you can do the mathematics, it will be more better. Then the mathematics become much more challenging. So that's the challenge I like actually. So those who are interested in mathematics will have tons of problem which is not solvable yet. But so everybody is getting the point that at this point what we are trying to find out, a relationship between, so how the way this employee relates to the budget, and you give me a relationship. So this is simply data visualization in a two-dimensional setup, and its simple plot is called the scatter plot. This thing can be extended to 3 dimension, but after that things get complicated. So if not, then what to do? So then that's the question is becoming, when the relationship cannot be explained in the mathematical way, still we like to have some kind of approximate relationship, and the regression analysis comes handy. That is the regression thing. So there are 2 types of regressions mainly it would go. One is called the parametric regression, another would be called the non-parametric regression. What is the parametric regression would be? The parametric regression would be, I should be able to explain this relationship with say only few parameters which would have some meaningful way. Okay? Why it is so? Sometimes not only for the prediction, also you like to explain the relationship, and that's why the parametric relationship oftentimes helps. It explains the relationship as well as it predict the thing. But sometimes you are not interested how these 2 things are related, you are just interested in prediction. In that case, oftentimes non-parametric regression could be useful. So we'll go one by one. So if I have to think about the parametric relationship, the first phase you have to think about from the data. Again, you can be a good data scientist only when your intuition is very clear. And that intuition, for that intuition, you don't need to be a good mathematician. You really need to be a good practitioner. So first thing what you have to think about, that I accept the fact that there is no mathematical relation, but is there any mathematical relationship which I learned so far? My life is very simple. I learned only up to calculus or not even calculus. Can I use one of these existing mathematical tool to explain this relationship? So now tell me first, from your school level algebra, what is the mathematical relationship you first learned in school? Line, exactly. So what is the line? Line means we know in a Cartesian system y equals to a plus bx. That's the line equation, right? So there are two parameters. Typically it's called the parameter. A is called the intercept, b is called the slope, everything you know. So let's think about, can I fit a line? So again, I think I missed one thing. You have to intuitively you have to find a trend. So here everybody kind of said that there is an upward tendency, but upward tendency can happen many different ways. Like it can happen, this is also like this, all are upward tendency. So little bit of curvature also is an upward tendency. But if it is a curvature, then this formula may not work. So most likely here might be somebody can think about, oh, there could be a curvature way, like the whole relationship like go like this. But if you think, you can think anything whatever you like because you know the mathematics. So you can think about this. But note that somebody might think about, I know this part. Instead of this relationship, probably I can go like this. So very typical example what I try to give. You have you are doing the cycling through this road, okay? So if you are a perfectionist cyclist, you would go exactly in the middle of this road all the time. And if I am a handy cyclist, what I will do, I will just go like this. But I would not be completely sidetracked. I will also reach to this point probably faster than you and much more reasonable way. I don't need to be expert in that much. So here is this the trade-off will come from. Did you do so? Okay. Here is the trade-off come from. So you can think about any kind of mathematical portion, but you may not gain much by avoiding some simplistic thing. Everybody is clear? So where we are moving? So what I'm trying to say, if you have the option, if you like, you do it, but end of the day, you will be the loser. End of the day, I'll be the gainer because I'm using shortcut way and I know what I'm doing exactly. So boils down to, first through the visualization, we kind of thought about the trend. Then there are number of possible trend. We thought about the simplest one, two way. One is we are not losing much, and second reason is we know straight line equation very well. That's the reason we are doing. Some point of time I'll tell you that how powerful this straight line thing is. Even if you do like so much curve, you can put number of straight line and you can pass this whole thing. So eventually it will come. But in any case, so if you like to do that, then the idea is you draw a line. But how do I draw the line? So if you use the R, which since I am in this screen, typically what we like to do, line. Oh, I think I'll wait. So all of you have agreed that this trend we can capture using our simple mathematical understanding of a straight line. So then what we are tending to? We are tending to put a straight line here. Now, how the way I draw the straight line?
To know about A and B.
We need to know what is the A and B. So how do you know the A and B? How do you know what is A and B? Eventually we'll use the R, but just I like to go a little bit more so that you understand how the way, what is the meaning of A and B, and how the way I'll do the A and B. How the way we'll do that.
We can take any 2 point and calculate the slope.
You can take any 2 point, calculate the slope, that's fine.
And every time we have the slope, number of slopes. We can have average.
So basically, and why you are going to say, why you are saying so? Because we know to draw the straight line, you just need 2 points. And why you said this, you take the average, because you can draw number of lines, and then each time you can, because once you have the line, you can calculate the slope, and then you take the average. Okay, then that's fine. So here is the whole, let me try to, I have other one more plot. Probably I try to explain what's the mathematics behind, okay, instead of writing this. And then I'll say how the way in mathematics you can do it without doing any part. For time being, I'm going to use a different data plot. So in parallel, let's discuss another example, okay? One example we have in hand, I know that, oh, that average now changed, by the way, but we have the data saved. So let's take one more example. Similar type, exactly similar type. A building maintenance company plans to submit a bid to clean 40 rooms in an office complex. Okay, because you have number of buildings in campus, then there is a vendor who made the bet it for how much they can clean all this part. But when you bet it, how do I know how much should be the winning bet? You don't like to lose them, because you can win if you say that I will do in way cheaper, but then your business may not run. And if you give way high, then again your business may not run. So how do I know a reasonable price? How to bid? Exactly the same way, you will probably go number of existing buildings around, and then you will see how many rooms are there, and then you try to understand the relationship. Once you understand the relationship, you can see how many for the 40 rooms for the new building, then you can just predict. So first prediction, it can happen, you can just take the average as the way we talked, but we all agreed that average will not be very reasonable unless you are a very lucky guy. So that's what we should develop a relationship. To develop the relationship, so essentially how much cost? The cost here again you are thinking about that incurred by the company is the proportional to the number of cleaning crews needed for this work. Like in our case, in previous example it was the number of employee, here number of crew members you need to clean this thing. That makes sense? So the question is, how many crews will be enough? If I know how many crews required, I should know how much cost it would be. So you need some data. Suppose you collected the data from 53 days from different buildings, and part of the data look like this. In this way you have number of data point. here is the number of crew members and number of rooms cleaned, like 16 crew members 51, 10 crew members 37, 12 37. If I look at just 6 data set, you apply your simple mathematics, I don't think that you can see a clear relationship here, right? But certainly there is kind of upward tendency. If you have more room to clean, you require more number of crews, but it is not exact proportional, it is not that way. So of course there could be, in any example there could be many more, but we are trying to understand at this point with only one, and then the whole idea would go for many more examples. So for this one, again, for the data visualizations, if you look at this data visualization, this was the whole data set. This looks like, so what it is this, that means you get 2 crew members cleaned. Some cases they cleaned like less than 10 rooms, sometimes they cleaned more than 10 rooms, because again always it is not clear that 2 crew members, they are cleaning in this building 5 rooms, means that in other buildings they will be also cleaning 5 rooms. They might be cleaning 6 rooms. So it varies. It's not completely mathematics, because all other factors are there, right? So that's what this variation you can see even within these things. So this is for another purposes, actually I said I will come back up maybe if I get time. But again, in any case, you like to make a relationship between this number of crews and room cleans, and everybody kind of agreed that there is an upward tendency. Again, you guys can argue that it is kind of parabolic, all these things. We can do this part, but at this point, let's like to fit a straight line, which we'll be calling as the simplest possible thing. If I can do the simplest possible thing, then I'll think about the complicated one. Right from the beginning, we don't need to. So the idea is we all agreed about that there is a linear tendency which would go in an upward form. So we can thus draw a line which best represents the points on the scatter plot. Now how do I draw the line? Now let's look at this thing. So this was your plot, right? You just take 2 points. You can draw a line, right? That's your line. So if this is the line, suppose I take, then what is the thing? That means this line representing the relationship. Now if I get a new building, if their number of rooms is right here, then I'll project exactly this, and then I'll find out how many crew members are there, right? You will be using this thing. The question is, how do I know this line? Because I could have drawn, because when you are so simplistic situation, then all these data point may not be needed, but we need to, since the data is useful, I'm trying to say that essentially for this mathematics purposes, you just need 2 points and you do whatever you like to do. But that's the way statistics can, or the real answer cannot go. So let's think about, how about if I would have taken this 2 point? Then I could have drawn line like this. Why not this line? Let's argue this way. Why not? Because first thing, all of us agreed already that we'll just use a line. This is the simplest way. If I use this line for the same guy or the same number of rooms, if I do this thing, then my answer become different even. So if I take this one, my answer would be 1. If I take this one, my answer would be different. But that is not acceptable. Given the same data, everybody should be able to give the same answer if my model is exactly right, or this is the best possible model, then this should be the answer, should be the unique, right? So same way, you pick another 2 points, you can draw number of lines. Then how many lines you can draw? As many points are there, choose 2. So think about, if you have 50 points, 50 choose 2, how many lines you have to draw? Whole day and night you will be keep drawing the lines, right? Or if you are using some computer, even computer will be keep drawing the lines. That's the, you have to do that thing. So how to find that the best line or the identity finder? So what is something called this is called the least square estimation. But what exactly it is meaning? So least square, again, that's the mathematical term. But before that, what you should do, essentially for any given line, suppose you have this line, any given line, if I use this thing, these are the real data and this is the fitted line because that's what the line fit. Then this is the measurement of the error. So for this blue line, for these two data point, this is the error, this is the error. I can calculate this error. Physically you can calculate the error even, right? And in the coordinate system, since you know x, y values, you can calculate the error. So then given a line, you calculate all this error from this line to all observed data point. Same way you do for this other one. Same way you do for the other line. As many line possible you do for that many line and that many calculation of the distances. And take sum of the distances. And the idea would be the line for which the sum of the distances would be less, that should be the better, because what you want, exactly what initially you wanted to pass the line through the as many point as possible. In reality, no way I could pass through all the lines, but I will try to pass through as many lines as possible. That's what we have been trying. So for the line for which some of the distances, so distances you can think about some kind of error, the smallest, that line should be the preferable. So for example, if I calculate the distances for these three lines, then here is the distance measurement for this particular three line. Again, sum of the distance means, like for this one, I calculated distance from each of the points from this line, and sum of the distance is this. For this line, sum of the distance is this. For this line, sum of the distance is this. So if I have this picture, which line I would prefer? Obviously, I would prefer the distance is 54, so this green line is the best line in this sense. Okay? So truly, I get a unique line. How to get a unique line, that's what we talked about. And idea-wise, this works. Now, how do I get that unique line? To get that unique line, you need to apply the mathematics behind. So that's called the least square. That's what the least square is coming. Essentially, theoretically, what you do, theoretically you calculate. This was your formula for this line, a plus bx, and this is your observed data. So you are taking this distance from the observed data, and this is for any given a, b is one of the line. So this is kind of the error from the observed data, and this is the line, this is the error. And you are taking the square of the errors. Again, for mathematical reason, you are doing the square. You could do some other things, absolute, all these things, but square, because there are lots of good properties, etc. We don't need to go that technicalities. Okay? So, but what it gives me, sum of the errors means as many data points are there, you are just taking the sum of all this error. And then you are finding A and B such that this would be the minimum. So what does it mean? That means I calculated all possible values of A, B. That means all possible of pairs I have already checked, and for which values of minimum would be that values of A and B, I'll take it. So by using the mathematics, actually you really don't need to fit the line for each possible pair, but actually conceptually you are doing that thing. Then we are bringing the mathematics back, apply that mathematics, which gives me very quickly this answer. And how to find this thing? You apply just basic calculus, and that should be the thing. And if you use the R, then so that's the idea behind how to find a basic the regression line, right? Since I am here, let's complete that equation. So using, as I said, that using R, this would be very easy. So here this for the completeness, intercept means your A estimate for this equation is 1.78, and the estimate for the B is 3.79, which called the slope. So the equation becomes rooms cleaned, like number of rooms cleaned, that equal to this plus 3.7 times number of crew members. So that's the equation. Now what was our question? Our question was, if I have a room of 40 rooms, then how many crew members I need? So I'll just put 40 here, then I'll solve it number of crew here. You can essentially see that on an average about 3.7 rooms are cleaned by the per crew members. So if I solve this part, essentially, as I said, that 3.7 rooms cleaned per crew members. So if you have a 40 rooms, then you are multiplying these 40 rooms by this part. Eventually, you are getting roughly 10 crew members you need for this to clean this 40 number. Now, if you know that 10 crew members you need, you know how much you will put into your bid. Because per crew members, you know how much cost it takes, so you will bid that much to get that tender on behalf of you. So simple way. So now, if all this thing model is valid, everything under this setup, you can think about it is again this is a reasonable number, but now we can also calculate all these things, how likely this would be right, exactly all sorts of things I can calculate if I believe on my model. And all this theory is well established for this type of setup. So you should just, in reality, what you should do, you just take or you just justify your model is the best possible model for giving the data. If you can justify, because all mathematics is well established, then you should be able to calculate how much error you have made, all sorts of things you can do that part. Okay? Okay, how about since we are in this rhythm, so let me then finish the other one. So everybody is clear what is the regression is. And this is the simplest form of the regression, and you can see that how practical it could be, very useful practical solutions it can provide you, provided you understand what exactly it does. But also you have to understand some of the assumptions I kind of explained. So if it failed, then why it is failed, you have to always keep in mind. In other words, when the data visualization is very, very important. Had I have these 2 points which are not following the same way, my answer would have been fairly wrong. Then you would say that, oh, I did my regression because I learned regression in the class, but you may have learned regression in the class, you did not really learn the data. And that's why your result could be garbage. But if you apply really right way, it can give you really sensible answer. Make sense? Okay, very good. So then let's go back to our ongoing example, which is kind of the made of, oh, what happened? Here it is go. So this was the thing again. We all agreed that there is an upward tendency. So we can find, so first thing, since this was a new data, our answer, if I do not use the regression, our answer would have been, let me just do the average here for the new data set, revised, oh sorry, $534.88. So this is approximately 535. That's the budget, right? So what does it mean? Without asking any question, you are providing the government and advising. So basically, as an advisor, that you need about 535,000 crore or whatever this number of amount of money. Doesn't matter how many employee he's thinking. If he's thinking number of employee for 2,000, 3,000, doesn't matter. Everywhere your answer is same. Everybody is getting what we are saying, right? But let's see if I would have applied the so suppose our objective, the government is now saying that, oh, we are thinking, say about we'll put how much employee, maybe, so these are the numbers, so it should be in kind of the ballpark. Maybe we are thinking about, say, 3,000 employee. So without doing the regression, your answer was, still your answer was, for the new IIT with having 3,000 employee, you need a budget of 535,000 whatever, right? That was your answer. So let's how many employees I said? 3,000? 3,000. So 3,000, this is the answer, right? Now let's do the regression here. If I do the regression, then essentially it is what is the linear LE or LES? LM. So if I do the LM, then this should be command should be revenue budget curly. That's a very simple one. See that otherwise you have to do all this mathematics. You have to calculate the sum over yi minus a, all this formula. We can provide the formula. You can do all this part. But probably here we don't need to. So you can look at the formula if you like. Employee. That's LM. All right, so you got it. So we got B equals to something is wrong? No, it is right. It's fine. About 1. We can think about it's about 1. Right? 224 plus 0.1, whatever it is, about 0.1, right? So now your estimated line is I cannot write here. Estimated line is your y hat, that equals to whatever this plus 0.09 times number of employee. Now you predict how much would be the budget. Yes, which one? This is 0.099. So you can approximate it, as I said, that you can write it 0.10 just, okay? And this is 224, you can just approximate with say 224. Just take the answer 224. And what we are projecting? 3,000, right? So for the 3,000, my budget would be, then I'll take 224 plus 3,000 times 0.1. So the budget becomes 524. Instead of 535,000 crore, you are now saying that you required 524,000 crore. So your answer changed quite a bit. And now how do you validate that your answer is better? Because if you look at this data a little bit, since you are doing the data driven way, if I find another IIT which was similar number of employee, exactly same or close by, actually there was one, 3,000. How is there any more 3,000? This is the 3,000. So for this 3,000, the budget was 450. So if in that respect, which one is the closer? Your error reduced. 450 was initially you are saying that 535. Now you are saying that 424. At least it error reduced. This error could be much more reduced if I had, again, when you are doing this thing, note that for this data, you can find out how much is the total error. So if the total error is much less, then this error also can reduce. But that you cannot have much more because this is the only data you have. But if I have more data, if I have a better data, probably I could have done better. But here what I am trying to say, it is indicating that if I have a regression relationship and if I apply the regression, then my prediction improves. That's what I just said. How much it will improve depending on what is the data I have in hand, what kind of relationship, all these questions. But simple tool regression works. That was my claim. And here what I am giving the proof that with a simple, as the way we talked about all this example, the prediction, the true value, if I use the regression based prediction, that is kind of the closer to the true value than if I just use the simple flat mean. And the whole reduction would depend on how good your model is, how good the model fits the data. Those type of things will come in. Okay? So hopefully I could convince you that what's the use of the regression, and regression helps. That's the only part I want, because I'm not solving realistically real problem, because then you have to have the data, and what is the remaining part you have to look at. So all these things a good understanding of regression analysis would help you answering many of these things. Any of the predictor feature useful in predicting the response, that's what we already talked about. But whole model building can help you. If, in this case, we had some idea like number of employees related to this thing. In some cases, you don't have the idea. But from the data, we like to know. From the regression analysis, we like to know. So it can help, yes. How good the model, this is the first important, how good the model reflects the data. If your model really reflects the data well, the improvement we talked about, it could be lot more better improvement. You can see profound improvement depending on how closely your model is looking for your data. So in other words, sometimes can I use my model and I can completely regenerate the whole data? If I can, which is not possible, but if I can closely regenerate the whole data, that means my prediction based on that model should be very good. So all these things need to understand more details, but the basic foundations of the regressions things in this type of prediction you understand, I hope. And what we did, and very basic simple linear regressions. And you will see, if you learn some of the other part, you will see that simple linear regression is essentially the building block for any of the complex procedures. And very weird type of relation, very nonlinear relationship, we can actually explain through the linear relationship. It is possible, and that's why it is very important to understand this linear regression very well. Okay, so what you should do, probably just build up some data, download some of the, if you have already done, try to understand some relationship using this type of techniques. If it doesn't hold, say for now, if I go back to my previous example, a previous data point, so if I go back to this previous one, the previous one was this one, right? So think about, I can partition the data like here. Can I think about one line here, one line here? If you can think about, then what is the next stage we have to think about? How to combine these two lines. So basically, you got the right or the what you need. It's kind of sometimes if you are a good engineer, just one tool should be good enough. You really don't need 100 tools. But if you are a lousy engineer, you need 100 tools. They sell 100 tools to the people like us because we need every different tools for every different purpose. But the engineer just who understand everything, one or two basic things you need, and you use it all different way. So it exactly goes exactly the same thing. Even it is in this case, nobody would say that it is a upward tending thing. It's kind of this and this, but you should be able to do it. Of course, you have to understand when the model works, when the model doesn't work. For example, if I break it up here, maybe this part I can fit little better than this part because this is very sparse data than this part. So if your model doesn't work, then you have to start thinking about why my model did not fit well. Probably the data is so sparse that you could not fit these things. Okay? So what does it mean? That means what I'm trying to say, you should understand the linear regression way better than what is written in the textbook. Textbook does not give you so much other than giving the formula. But formula does not make you the data scientist. Okay? Okay, all right. So yeah, so we can have it's a good time. So far so good? All right. Okay, so we'll continue.